All right. Ooh, sorry, don't want to talk too loud. I'm not used to using a mic. Usually I project, so that'll be news to me. So we'll make sure I don't get too loud. Before I start, I'd like to introduce myself. My name is Dave Rasmussen. I'm the North American Safety Manager for Rockwell Automation. I, for the most part, take care of all things safety for the western half of the U.S. and western Canada. When I say all things safety, and I also want to say hello to the people we're actually broadcasting live on Facebook Live as well. So we also have some people in the world that's going out. I scared Tanya a little bit because my wife told me to never post anything on social media. So this is my first attempt. Hopefully I don't screw it up. Give you a little bit of an idea. I am kind of all things safety. My job is a little bit different with Rockwell Automation. I cross all the different business units in regard to safety. So I also support safety components, if you're familiar with that, safety drives, motion controllers, all the way to the services organization. We take a look at safety as really something that is kind of an umbrella. It affects all of the different business units that we deal with and all of the different products. Any of you in the room and or out on the web that have actually applied any safety devices to machines and or safety functions, what we call them, on machines, are familiar that it comes in all different varieties and things to that nature. We'll touch a little bit on what I'll say is some of the technology changes that have come into it as well. So I want to welcome you to this session, SS10, which is entitled Functional Safety Standards in the Changing Landscape. So I'll touch on the North American standards, how we approach it here in North America, and then how standards and the application of safety is actually applied globally as well. So we'll get a little bit of mix of both, and I will give you what I'll say are opinions on probably what I would be concerned with in the direction that I would move if I were implementing safety on machines as well. A little bit of my background with Rockwell. Next week, Wednesday, I will be celebrating my 40th anniversary with Rockwell. So I've been around for quite a while. I think that classifies me as quite a while, and I think looking around, I've been at Rockwell longer than I believe at least half of this room has probably been on the face of the earth. So that might have something to do with that as well. But it's given me a lot of different opportunities to be able to get engaged in a lot of different products and a lot of different applications. For the last 15 years or so, though, I've been focused primarily on machinery safety. When I say machinery safety, how many people in here have a little bit of a clue what I'm talking about, the application, okay, good, of safety on machines? When we talk about safety, that might actually incorporate several different things. Anybody in the room here involved in process safety applications? A little bit different than machinery safety and a little bit different approach when we start taking a look at that, but I'll touch a little bit on that as well because standards kind of affect that and the way that they're differentiated. We'll touch on that as well. So my forte is mostly in machinery safety. I have also gone through some training and certifications on process safety as well, but this is mainly going to be focused on machinery safety. Just so I can get a little bit of a gauge as well, in the room here, how many people in the room are system integrators and or people that are designing systems on machines? Okay. Good portion of that. How about machine builders, people that are building machines, and you could be both. And then what I would say, people that are actually utilizing machines within their manufacturing facility or within their plants, so end user situation. So I have a really good mix. So I'll make sure that I don't approach this from one particular way and kind of cover all of that as well, because you will have different needs and concerns depending on where you're coming from, but this will be applicable to all of those different varieties. So when we start thinking about things of that nature, then the responsibilities that get into it as well. North America does approach safety, what I would say is in a little bit different flavor than how they do it in Europe, but the world, I think everybody can agree, the world's getting smaller. So when I think of that, how many people in the room here, when we start thinking about their company or the machines that they're working on, are either, their company is either a global company, in other words, working throughout the world, they're a system integrator and or a machine builder that are building machines that are consumed worldwide. How many folks are affected that way? How about just North America centric? and alone. So those of you that are just working with machines that are focused on North America, we'll certainly touch on that, but I'll give you some ideas of why you may want to consider utilizing global standards as opposed to just strictly the North American standards. And I'll also make sure that I mention when it's my opinion as opposed to something that's necessarily fact, because those may be two different things. So the section itself, this session is designed to be kind of an introduction to those functional safety standards and the beginners. So I will break it down in that realm so that we can understand where they come from. But I will also talk about some more advanced concepts and things to that nature. So we'll talk about applying safety on machines, and then talk a little bit about how that's driven both here in North America and then in Europe or the EU, and in that effect as well. Let me start off first by talking from a general sense, and this would be both North America and in the EU, or from a global perspective. When we start thinking about things to that nature, most standards, when we think about standards, are broken into three different types. There's a type A standard, type B standards, and type C standard. Type A standards generally have are standards that are written around general concepts and may be considered what I would say are top tier standards. So if you think about standards in a parent-child relationship, type A standards generally would be the parent standard. From a safety perspective, that standard generally happens to be 61508 is the standard. It's about 7 to 9 sections. It's about as thick as a phone book. And that covers safety when we think about it, and from a standpoint of all different and across all industries and all different types of machines. So it's not any specific industry or any type of machine. It crosses all of those boundaries. So when I mention the difference between machinery safety and process safety, both are actually based on the 61508 standard. So that standard, that A-type standard, is a standard on all of those standards are based on. So that happens to be the parent. Tony, that happened to be doing a security talk prior to this. Now security standards are also referencing 61508 in the security and cybersecurity of the products and the devices that we're using on machines as well. So general concepts, and we'll use an example and talk about an example of an A-type standard that we use, which is EN ISO 12100, which is a standard that talks about the methodology of doing a risk assessment on a machine. So we'll use that as an example as well. Then the standards break down into what we call type B standards. Those standards are usually wrapped around a specific industry and or developed around different types of devices. All of you have seen safety devices, I assume, used on machines or in your processes or on the equipment that you're interfacing with. So there is a standard that is written around interlock switches. So if you've seen tongue interlock switches, RFID interlock switches, and the use of those interlocks and the application of those interlocks, there's a standard that's written around that, EN ISO 14119. There are standards that are written around the design and implementation of things like light curtains and laser scanners. Those are B-type standards, so the design of those devices and the implementation of those. Anybody ever see an e-stop on a machine? My assumption is going to be yes. At least in North America, you'd have to have a pretty doggone good reason not to have one on a machine. Believe it or not, there's a standard written around the design and implementation of e-stops on equipment. EN ISO 13850 happens to be the standard that surrounds that. Interesting question always comes up with e-stops and gets into the discussion and people talk about it. Probably one of the most widely misused components that happens to be on a piece of equipment. In many cases, operators and people are using e-stops as a cycle stop on a machine. I've had examples where I've gone out and worked with customers on machines where they've actually literally had to clear all the work in progress out of the machine every time an e-stop was pressed. But if the operators haven't been trained appropriately and haven't been shown why they should stop the machine the way it was intended to be stopped, it would tend to be misused. May come as a surprise to people in the room, emergency stops are not considered a safety function. They're considered complementary to the machine. And we'll get into a little bit of a discussion about that when we talk about it as well. When we put safety on machines, i.e. safety functions, generally we're putting them on the machines in a mode where we call it a alternate protective measure. It's something where we're doing something frequently enough that we don't necessarily want to have to do a lockout tagout event every time we're interfacing with the machine. So we'll get into that discussion as well. Where I get the idea and what I would say is the basis of an emergency stop being complementary to the machine, where I'm going with that is that there are very low, the hope is there's very low demands on an e-stop. In a perfect world, how many times should an e-stop be pressed in a year? Hopefully 0. Or my hope would be maybe once a day, 365 demands for a verification that it works properly. Go ahead, sir.
Just a quick, pull cord is just like a e-stop, considered as an e-stop too?
Yes, so the question is a pull cord, if you think about pull cord systems that are on machines, they can be utilized and typically are utilized as an emergency stop that's extended over a wide berth or a wide area of a machine. So yes, they would classically fit into the realm of what the definition of an e-stop would be. That is correct. Any other questions before I go on? So we'll talk about that. So then we have those, we have those B-type standards that exist around the design and development and application of those devices. We also have B-type standards that surround around concepts for being able to apply safety devices. Guards and safeguards are typically classified in two different varieties, a separating guard and a non-separating guard. If you think about a separating, I use that terminology, a separating guard, what would somebody, help me here, define as a separating guard? A physical guard, something that's going to create a separation between the operator and the hazards that happen to be on the machine. When I talk about a non-separating guard, what would an example of that be? Light curtain. So something that would be to that nature. When we're applying movable guards that may have an interlock associated with them and or light curtains, does anybody know what we have to do to figure out where to mount the light curtain and or the guard away from the hazard? Anybody ever hear of a stop time calculation or a distance calculation, safe distance calculation? There are standards written around determining what distance or at what point those particular guards have to be. So the example of that would be a EN ISO 13855 and or ANSI B11.19 have formulas that you can utilize to determine where those guards have to be mounted. Again, a B-type standard. Then we have C-type standards, which generally are written around and utilized for specific industries. Anybody in here build a packaging machine or associated with it? So we have an example of that. There is a safety standard that's written around the specific issue with dealing with a packaging machine. Do you happen to know what it is? ANSI B11.155.1? That's the one. So there you go. So we have standards that are written around that. One that's probably a little bit more common that you probably have heard of would be the robotics standard. ANSI RIAR 15.06, or the European equivalent to that, EN ISO 10218-1 and 2. The robotics standard. Why do we have standards written around specific types of machines? We call them industry standards, because they're dealing with the same types of hazards over and over again, and or common hazards that would be associated with those types of machines or those types of applications. So that kind of breaks it down, and that's both when we get into North America standards, which typically are things like ANSI standards or European standards. We have both of those. So I wanted to go through a description in that regard as well. One thing that would be here, by the way, these presentations will be made available to everybody that is here. I put an active link on this page. How many people in here have taken a look at this booklet, Safe Book 5? Okay, I would ask you, if you haven't, go ahead, download a copy of it. There was some, what I would say, serious time put into that booklet by some pretty smart functional safety engineers. Go ahead, sir.
Is it different in the Safe Book 1?
Yeah, it's an iteration. It's been updated to more of the references for current standards. and current applications. So being Safe Book 5, the question was, is it different than Safe Book 1? Yes, it has 4 extra numbers added to it. In reality, what it is, it's the 5th revision of this particular book. So as we do revisions to it, the number will change. We also have one for process applications, Process Book 1. So we're in the first iteration of Process Safe Book. This is the 5th iteration of the Machinery Safety Book. But what's nice about this, it walks through machinery safety through the steps that are required to be able to apply safety to a machine. So it's a very good reference. And what I'm going to touch here is a very small part of what's actually covered within that book. So let's talk about North America. How many people in here have heard of OSHA? How many people in here are best friends with OSHA? So the hands go down pretty quick. So when we think about that, we're all aware of OSHA being kind of the governing body for safety here in North America. When we start thinking about that, one that I'm typically involved more so with is the CFR 29 Part 1910. One that I'm involved with day in, day out is CFR 29 1910.147, which happens to be the lockout tagout standard, or the lockout tagout regulations from OSHA. Kind of give you a little bit of an insight from OSHA. Interestingly enough, does anybody know about when the OSHA regulations or the OSHA Act was written? What is it?
70s.
So it was written in the late 60s. So there's your trivia question for the day is, what president signed the OSHA Act into law? It was the William Steiger Act, by the way. What was it? Nixon. So the guy in the front got it right. So it was President Nixon signed it into law. So it was written in the 60s, signed into law in the 70s. How many changes, or how many, what I would say, drastic changes has the OSHA Act really gone through since that point in time? Anybody have any clue? Not a ton. Now they do letters of interpretation and interpretive letters on how to apply things, but the OSHA Act itself hasn't changed dramatically when you think about it in the way that it was done, which kind of creates an interesting perspective. How much has technology changed since the late 60s? Dramatically. Now I will tell you, as a guy that's, as I said, been with Rockwell for 40 years, the amount of changes that I've seen, and especially the amount of changes that I've seen from a safety perspective, from safety components, and what I will say an integrated safety message, has been tremendous over that period of time. So it's been quite a change that's taken place. How the heck do we justify utilizing that technology and utilizing the devices that we're producing and meeting something that was written in the 60s or the early 70s? Do you think there's a little disconnect? Or how do we do it? What's the method? Somebody's got to know. Industry standards. So we utilize the industry standards that are constantly developing, constantly changing to be able to apply it. There was some brilliance when the OSHA Act was written. In that particular regard, if you go out and you take a look at the OSHA Act, more specifically even the lockout tagout standard and regulations that exist today, there isn't a whole lot in there that tells you directly what to do. It might tell you what the equipment needs to be, or things to that nature to certain respects, but it really doesn't give you guidance on how to apply that or how to develop an appropriate lockout standard. It keeps that wide open. There's a brilliance in that. The problem with that, the OSHA Act is what? It was signed by President Nixon into law. So I'm not picking on the government, and I'm not picking on anything to that nature in Congress and things to that nature, but how easy is it to get something signed into law nowadays or laws changed? Not too easy. They're not very efficient at it. So when, or if, they were referencing standards along the way within that OSHA Act, they would become law. By not referencing specific standards, it keeps it open enough so that as new standards are developed, as standards progress, we can continue to use them to be able to do the things that we need to do. So that's really part of that brilliance that was added into it. I think we all know when we start taking a look at it that the OSHA Act, and by the way, why was the OSHA Act created? It's a simple reason. What was it? Safety, yes, because people were getting hurt or people were dying. So there was a need, there was a reason why the OSHA Act was developed. Once the OSHA Act became and was signed into law. By the way, does anybody know where the framework from the OSHA Act came? Do you think that a bunch of guys got together and just started writing a bunch of regulations and trying to put it together? It may come to a surprise to you, but some of the standards committees that still exist today were in existence prior to the OSHA Act being put in place. A case in point, 1910.147, the lockout tagout regulations, actually utilized a pre-existing standard, which by the way still exists today. ANSI Z244.1 was the standard at the particular point in time. I'll give you the title to that standard, and it's going to fit in to what I'm talking about from a machinery safety perspective. The title of that standard is Control of Hazardous Energy, Alternate Methods to Lockout Tagout. I think that might have something to do with machinery safety and applying safety on a piece of equipment. May surprise you to the time. Anybody in here work along with people or work with people at your site or with some customers where they have the attitude that I've done it this way for 20 years, why do I need to change? Anybody run into any of those? Certainly, right? You see them? Doesn't happen to be any of us in this room though, right? Of course not. So when we start thinking about that, we run into those types of people that are reluctant to change. Sometimes the standards are reluctant to change as well. This is one of the things where I would say there are some gaps, and we'll talk about that right now, where some of, I believe, and this is an opinion, some of the North American standards that exist today are slow to change, and my fear is that if they don't start to change with technology and with the advancements that we have, there's going to become a point in time where they become irrelevant. And then the global standards really kind of fit the bill. So we all know the OSHA Act, that we have to create a safe and healthy work condition for our employees. Everybody's heard that, right? So the simple fact is that if we see a hazard, know of a hazard, or a hazardous condition, what do we need to do? Report it, fix it, address it, right? So we know that. And by the way, that's only 50% of it. Whether we believe it or not, the employee also owns 50% of the responsibility for their own safety as well. There is such a thing in this world still, believe it or not, a personal responsibility. It does exist, trust me. So we still have that as well. So we think about those types of things and where that actually applies. So we have things to that nature, and this is where we get to the case in point that Steve was so kind to add in, that when we said, well, how does the OSHA Act keep up with technology? It's the ability to be able to utilize existing consensus and or national and or global standards to be able to fit that in. That's really where the importance of those standards fit in, is the ability for us to be able to apply that. So we know that that happens to be the case. I have a bunch of different slides here as well, and a few different subparts in 1910.147. Obviously, the one that I'm generally dealing with is subpart J, which is the lockout tagout standard, and then obviously subpart O, which are the machinery guarding methods and ways to be able to do that. And then we have subpart S, which happens to be electrical safety. Anybody in here up to date? And this has only been now what, for the last about 10 years, we've been heavily involved in the implementation of that. Heard of NFPA 70E, arc flash standard? And you all love it, correct? Why do you laugh? Is it a difficult standard to apply? It really isn't when you get down to it. Now, it gives us an ability to be able to do it. That's a very good example of a standard that was developed to get us to address issues and or hazards that existed in our facilities or with the equipment that we were dealing with. Obviously, and people may not realize this as well, I get the question quite often, do I have to, and this is a question I'm asking, do I have to implement NFPA 70E? Is it a requirement by law in North America? Anybody want to take a swag at that? Okay, I got mostly no's and a couple of yeses. So what do you do? Or is it, you know, and probably the best example I had the honor of actually traveling along with the head OSHA compliance officer, and that question was asked. Do I need to or do I have to follow NFPA 70E? Go ahead, sir.
There's a difference between need to and should.
Okay, very good. And actually what OSHA would use those is a shall and a should. Shall is a what? Requirement. Should is a what? Very strong recommendation, right? And here's the case in point. That director was asked, do I need to follow or implement NFPA 70E? His answer simply was, if you're not aware of it, NFPA 70E was created at a direct request from OSHA to NFPA to develop an electrical workplace safety standard. So that might give you a hint right there, that it's important to them. But the thing is, can you develop your own electrical workplace safety program? The answer to that is yes, but then who owns it? Who maintains it? Who's responsible for it? So those are the types of issues that come up. Certainly, if I was going to implement an electrical workplace safety program, I might take a standard that's proven in use and been used before and follow it. Because what am I going to be, at least, what I would say is confident in at the point when I finish? That I've done something somebody else has done, and that standard continues to change as technology changes. Might not like the lockout, tagout, the hard flash standard, but I will assure you the reason that that was developed was because there were injuries occurring and something needed to be done. And really that standard itself, for you to be able to implement that and create that program, is a mechanism to be able to help create a safer environment. Doesn't mean that you have to follow all of the ins and outs and make it as difficult as possible. So then we get into lockout, tagout. And this is the place where I ask the question, when we start thinking about it from, especially from at least the people that are in this room. How many people in this room have a piece of equipment or a machine that they know that they can maintain, do everything that they need to do to maintain it and run it, operate it, set it up, where they can do that with absolutely no power applied to it. Unplugged and completely all energy sources removed. Does anybody know of or have a machine that can be done on? It's pretty rare. So what is it that we do? If I have a particular piece of equipment that I have to do some type of maintenance on that piece of equipment, and I have to have some type of energy still applied to it, how do I do that safely? That's the question. You know, when we start thinking about machinery safety. Is lockout tagout safe? I'll ask that question flat out. And I'm a functional safety engineer. I think lockout tagout is extremely safe if it's done, right? It's a manual process, or even done correctly, even to that point as well. And I can set this in a little bit of basis. I don't know if anybody's enough of a geek like I am and spends a lot of time out on the OSHA website, but did you know that there's a whole statistics area that you can go in and plug your company name in right down to the address and see every interaction your company's had with OSHA? You can look from a corporate level and plug in your company name and look at it from a high level and be able to see all the interactions that you've had. You know, if you're a machine builder and you're looking to be able to supply a piece of equipment to a customer, nothing wrong with going out and seeing where that customer has difficulty that might point you in a direction, and I don't want to say this the wrong way, of how they're going to utilize and use your equipment. You know, there's assumptions that we make, but all of that information is out there. My question would be, lockout tagout is extremely safe if it's done or if it's done correctly, but if there is still an issue, if it's so safe and it creates a safe environment, why does it rank in the top 10 citations every year for the last 15 years in a row? It tells us there's some type of a problem. So people are still doing things to a machine without isolating the energy. And I think we all agree there are certain applications and certain instances where we're going to have to interface with a piece of equipment and still have a certain amount of energy applied to that machine. So how do we do it? How many people in here have ever heard of the minor servicing exception? How many people in here take advantage of the minor servicing exception? Okay, so I will give you my definition of the minor servicing exception. There's a blurb up here, but I would say the good definition for me would be during routine repetitive maintenance events during the normal operation of the machine, you can rely on an alternate protective measure as long as it provides effective protection. Key word, and I put it in bold there, effective. Did I say equivalent? Do words matter? What's the difference between effective and equivalent? If I said that you had to provide equivalent protection, what would that be? It'd be 100% energy isolation. That is not what we're doing, because we've already determined we can't do that. Believe it or not, when you sit on standards committees and things to that nature, sometimes they start changing words. And a good example of that is on the ANSI Z244 standards committee, they wanted to change that word from effective to equivalent. That would change the entire ballgame, because we can't do that. Yes, sir.
We have equipment that requires alignment with a laser, that you have to have power on to do that. Technicians need to be in the machine or in close proximity. And so what we've chosen to do is we have blocking mechanisms that are inserted in between the moving parts of the machine, so it could move out and open up more, but we put physical blocks in that will preclude it from closing inadvertently and hurting somebody. That would seem to be fitting into what we're talking about.
I would agree. You could even take that a step further and use advancement of technology now that drives have what I would say is advanced safety functionality, and put it into a point where safe direction, so there again, the drive would only be able to provide what I would say is energy to the motor or energy to the mechanism, so that it would only be allowed to move in one particular direction as well. I worked on a system at a foundry anybody know what a Telfer system is? It's like a monorail that hangs from the ceiling. And there again, what happened is they had an instance where a car ran into one other car, pushed the car forward, and molten steel started to dump into the operator's cab. Not a good situation. Needless to say, they had to get to a situation where when those cars came within a certain distance of one another, they were only allowed to creep at a very slow speed. Once they came in contact with one another, they were only allowed to go in opposite directions. So advanced different types of functions that could be able to do that. So again, that minor servicing exception is really kind of where we live to be able to fit these safety functions on a machine. When I talk about a safety function, that consists typically of an input device, some type of logic solving device, and some type of an output device. The input device typically is going to be a safety input device. Logic solving device will be a safety device that's doing not only the control of the output device, but then in most cases as well, monitoring the condition both of the input devices and the output. You probably heard the term a safety monitoring relay. It does both of those functions, the logic involved in the machine, and then the monitoring for failures or faults of the equipment that's connected to it as well. So a little bit of other information, there's a lot of background slides that I have in here, talks about the types of devices that are required as an energy isolating device and things to that nature. Getting into this is where I said that both in Europe and in North America, we deal with both A-type standards and C-type standards. So A-type standards across all different industries, and then the C-type standards typically have to do with them as well. So I'm going to get past a few of these different things to that nature. We get into the different types of general requirements and things to that nature that surround around guarding. I used some examples of different types of guards, different types of flying chips. You know, if you had flying debris or things to that nature, we're probably going to use some type of separating guard that's going to prohibit those flying debris or flying chips from occurring. Or we might require additional personal protection gear like a face shield or safety glasses or something to that nature. Anybody know what the engineering term is for flying chips? It's one of my favorite engineering terms. A schwarf. So keep that in the back of your brain. You can look it up, check me on the internet. If it's on the internet, it has to be true. So flying schwarf would be like flying chips and things to that nature. So we start thinking about things to that nature. Fixed guards, in many cases, we may have hard guards that are on machines that aren't appropriate at all for the particular area of machine or the application. My guess would be if you have a hard guard over an area that a maintenance person has to access once a week, how many weeks is it going to be in place before it disappears? About one. I have a customer, week before last, excuse me, happened to be at a customer, they solved that problem. They just mounted all of their hard guards on with Velcro. So, it made it very easy to remove them and put them back in place. Probably not a good idea. So you might want to think where the types of guards are a little bit more suitable or what really truly fits. Point of operation, when we start thinking about that, that would be on a particular machine where somebody is coming in contact with hazards and or conditions in that regard as well. And then all different types of safeguards that I have listed here and industries that work with it as well. And I talked about subpart S and the electrical safety. How many people are familiar with NFPA 79? It is a safety standard for the implementation of machines in sites. When we think about the influence that Europe has on our standards, the influence that we have on our standards, this is a very good example of a North American standard that was developed that was accepted by Europe. Europe, for the lack of a better description, took a copy of NFPA 79, made a photocopy of it, put IEC 60204 on it, and they utilized that as their installation standard. So believe it or not, if you're familiar with NFPA 79, you're familiar with IEC 60204. They are more or less one standard, common in one. Different types of standards organizations, how many people have heard of ANSI? And then AMT, robotic standard, RIA, things to that nature, PMMI, the packaging industry. All of these different groups of engineers are in the business of developing and writing the different standards that go along with it. Give you a little bit of a different perspective from the EU. How many people in here have heard of the Machinery Directive? So the Machinery Directive, and why did anybody have a clue why they put the Machinery Directive in place? They had all these machines being produced and built by different companies with all different types of sets of guidelines and regulations. So it was pretty much haphazard. The idea of the European Union, and if you have anybody in here build a CE compliant machine, so you've gone through what I would say is an arduous task of developing a machine that meets all of the global standards. In addition, you've developed a technical file that exists for that particular machine, and it's in compliance with all of those standards. So that was really, the idea was to have a common set of goals. We start taking a look at, the EU, and I don't know if right now, if I need to draw a little X through the UK or not. I don't know, and it's kind of an interesting perspective, what Brexit's actually going to have on this, but my guess would be, because the UK does business with all of those other countries, they're still going to be building their machines per that requirement and that set of standards. So that was the idea, to be able to put it in. Is it fair to say, and any of you that have gone through the CE compliancy or Machinery Directive requirements of building machines for that, is part of the EU and the Machinery Directive, can some of it be perceived as a way to lock out North American machine builders from doing business in the EU? Those of you that have done it, a couple people's heads are nodding yes. I think I would be amiss, and again, this is an opinion, that some of that wasn't involved as well. Even like the requirement that where does your technical file have to reside? In Europe. So how do you do that if you don't have a facility or you don't have a company? Yeah, you pay somebody to hold the technical file. So I have 40 years with Rockwell. My retirement plan will be maybe to move to Switzerland, get a room about this size with a lot of file cabinets, and you can pay me to hold your file. I'm thinking that sounds good to me. So we start thinking about things to that nature. So, when we start thinking about that, it's a general requirements of being able to build machines. And again, they get into the same hierarchy of standards, A-type standards, B-type standards, and C-type standards. When I break it down, here are a listing of several of those different types of standards. I use the example, General Principles for Design of Machine, which is ISO 12100. We may be familiar here in North America with a standard that's called ANSI B11.0 in that regard. So we're very familiar with that. When we talk about machinery safety here in North America, you'll commonly hear standard referred to as ANSI B11.19, which happens to be a safety standard. In Europe, the safety standards that exist around the design and development of machines is EN ISO 13849-1 and 2 and 62061. 13849-1 and 2, if you've heard of the term performance levels, how many people in here have heard of that? Is it because your customers are asking for it or because you know it? Oh, that's a good answer. I like that. So, performance levels, when we talk about that, those of you that have been doing safety for 10 years may be more familiar with common terminologies that our customers use, like safety categories. So category B, 1, 2, 3, and 4. The big difference between those two, when we moved to performance levels, what did we do? We made the standard more complex, but we added the ability to add measures to how well our safety systems and or safety functions were designed. We took a qualitative standard and migrated it to a quantitative standard. So now when somebody says to me, design a circuit around performance level D, there's a certain expectation that at the end of that, I'm going to be able to show what its safety reliability is. In other words, its probability of a dangerous fault per hour. And I should be able to give you a measure of how well, in other words, a measurement of how well I can detect failures and or faults. And it will also be designed with a certain hardware fault tolerance designed into it. When people heard of category 3, also in North America, commonly referred to as control reliable, was defined as a circuit where a single failure fault would lead to the loss of a safety function, and if at all possible, identify that failure fault and not allow it to be reset and restarted. That's a hardware fault tolerance of 1. I have to be able to withstand a failure fault, and it still has to work. But do I have any measurements on the reliability of the devices? Nope. Do I have any measurement in the reliability of how good my monitoring or failure capabilities are? Nope. This is my plea to people. Start taking a look at the performance-based standards based on performance levels or still category levels, because not only can we determine what is required, but when we implement it, we can prove that what we designed meets what was identified or the risks that were identified in that space as well. So again, just where some of those standards fit into that idea. How many people in here have done a risk assessment? How many people in here have done a good risk assessment? Might be a big difference, right? What my definition of a risk assessment might be and your definition may be two different things. Risk assessment is not going out on, and by the way, anybody that has ever gone and or supplies equipment to customers, gone out and take a look at a machine, generally they'll walk you out and say, that looks hazardous, fix it. How do you fix it? You know, that's the real question. Without doing a risk assessment, I can't develop a functional specification for how it's going to work. Can't tell you how often, and I've been doing this a while, and I've suffered the same thing that you have. Gone through, listened to what the problems were, perceived on that piece of equipment, designed a safety function or some type of mitigation technique for the machine, go back several weeks later, and the maintenance guy will come up to me and say, oh, it works perfect for the operator, but can you put a selector switch on there that says safe bypass and shut that safety thing off for me? Anybody ever run into that? By the way, what do you think the first thing is when I walk up to a piece of equipment and I see a selector switch that says safe bypass? Probably an issue, probably a problem, probably didn't really address how and everybody, and by the way, when you do a risk assessment, it's everyone that has to interface with that machine and all of the different tasks that are associated with working on that machine. So you have to take that into account, where I can assure you, you're probably not going to develop a safety function and or safety on that machine that's going to meet what the requirements are. As a functional safety engineer and doing this for a while, I can assure you this. If you put safety on a machine, someone will test it for you. Guaranteed. There's a verification mechanism that is in place, and it's called the operators and the workers. So if you put it on the machine, they're going to test it for you. So my plea to you would be, if you're going to do it right. So then we start thinking about that. A couple definitions. When I talk about harm, that's the injury that would occur. When I say the word hazard, that is the source of the harm. When they use the word risk, that is the likelihood of the hazard causing the harm. When we think about risk assessments, that's really what we're taking a look at. Here is a methodology out of 12100 for a risk assessment. Machine characteristics is, what is the scope of the machine? What am I looking at? What is the speed that the machine operates at? What are the energy sources applied to that machine? What are the raw materials that are being used with those machines? Collect all that information. Hazard identification typically is where people are interfacing with the piece of equipment and the point, what we call point of operations, or where those hazards exist. Risk estimation can be calculated in many different ways, and once that's determined, that's our initial risk level. Our mitigation should be designed around what that initial risk level is and designed to be suitable for mitigating that risk to the best of our ability. Anybody ever see a risk graph? Based up of severity, what we call, and then the second step is frequency, or more commonly referred to as exposure, and then the last one is probability of avoidance. Anybody utilize the risk graph out of 13849-1? So 2x3 matrix. Is there a little subjectivity added into the application of that risk graph?
Yeah, you can, the best way I read it, you can extract death from anything. So
Right.
you have
Well,
to
that
be
is serious,
reasonable.
I think we'll all agree. So, yeah.
You have to be a little bit reasonable, and yet still, yeah, there's a lot of subjectivity.
So I asked him if there was a little subjectivity. You couldn't see it, but he closed his eyes and rolled his head back. I think the answer to that is you bet. So when we start thinking about this, it was purposely written around that subjectivity. It's a B-type standard. It's for all machines and all types of machines. So we're looking for things that are a little bit more finite, and we can get into that. How many people have seen this risk graph? Comes out of the robotics standard, relatively new, so that comes out of ANSI RIA R15.306, which is a technical report. Take a look at it and see what we have down here. There's only one path to get to very high, which actually happens to be performance level E. This is an opinion. You think some people work these risk graphs in the design of them with the intent of avoiding one particular area and then work the graph backwards? I'll give you an example. The robotics standard considers a moderate injury anything that would be severe lacerations, multiple days in the hospital, no guarantee that you return to your same job after the incident, and the loss of a fingertip but not a thumb. Why the fingertip but not a thumb?
You've got 3 more.
Yeah, actually, the robotics standard did not like my answer to this, because if you use your thumb, you can't use your smartphone. The jokes are bad, I'm sorry. So but when we think about that, so that happens to be that risk graph. What I would ask you to take a look at, I put this in the slide, this is something called the hazard risk number system. This is something that can be used in conjunction with those risk graphs. It quantifies each of those different areas and ends up having, I think it's 6 different selections for severity, puts a number to it. 7 different selections for exposure, puts a number to it. You can get an initial risk number. Once you apply your mitigation technique, you can go back through, estimate your resolving and your residual risk, and then you can show a reduction in risk. So that's where they like the
We've got a
questions.
couple of Facebook Live questions, if you will.
Okay.
Are there any updates to IEC ISO 17305?
Oh boy. Okay, so there's somebody out there that wants to know if there's been any movement on EN ISO 17305 was a push to take EN ISO 13849-1 and 62061 and merge them into one standard, which I would love. So the last thing that I had on that, it was put on hold 1.5 years ago, and I don't believe that committee is meeting again for another 4 years. So needless to say, those 2 standards committees did not get along well together.
Has
In that
the
migration
use,
path.
has
Go ahead.
I have one more.
Yep.
Has the use for HRN ratings increased?
Yes. So, and what's being pushed by the use of these HRN systems is, again, that quantification of using very subjective risk graphs and being able to quantify them. It's something where EH&S professionals really like the HRN system because it shows the ability to be able to show reduction in risk through a quantified measure. Yes, sir.
I'm a machine builder in our group. We don't build a lot of machines, they don't normally go out of our plant, but should we have someone that knows this as a single person, or should every one of the machine builders know this as well as you do?
So my response to that is I probably would have one person that probably is the go-to person for those standards. The reason for that is they continually change. And if you're not applying it on a day in, day out basis, the likelihood of staying up abreast and staying aware of what's going on would be very difficult. So trying to train that in mass would be very difficult. But I would have one particular person assigned to functional safety. That would be the go-to person. But each of those people that would be involved in that process would learn through it and utilize them as a resource. That would be my suggestion. Any other questions? So I apologize, I know I went really fast. I have a lot of information I wanted to cover. Thank you very much for your time. And if you don't mind, if you go out and